Today we're going to talk about our exponent rules, and most of this should be review, but stick with me, especially because you may have forgotten those little tricks. Okay, so you can see that I have my calculator open because the first couple we are going to be dealing with just numbers, no variables. So our first example, we have 7 to the third, or 7 cubed. If we were to do this longhand, that means 7 times itself 3 times. It's not 7 times 3, it's 7 to the third. So if I'm in Desmos, I'm going to do 7 and then my A to the B button, 3, and I get 343. Part B, I'm going to use the calculator first, and then I'll show you how to do it algebraically. So if we do 2 to the exponent of -4, we get a decimal, but remember we convert back to a fraction. We get 1/16. You may be thinking to yourself, how did we even get there? Remember, if you have x to a negative number, we can rewrite that as 1/x to the positive exponent. So we can rewrite 2 to the -4 as 1/2 to the positive 4. And if we double check in our calculator, 2 to the 4th does get us to the 16th. So we get 1/16. In part C, we have a fractional exponent. Remember when we did a square root and we took the square of both sides to get rid of the square root? The reason that we could do that is because our radical actually becomes a fractional exponent. So if you have the nth root of x, that becomes x to the 1/n. So for example, if I had the 7th root of 5, that would become 5 to the 1/7. If I had the 121st root of 6, that would be 6 to the 1/121. So I can rewrite this with the square root. My -8's on the inside, the 2 is on the outside. So now we're looking to take the square root of -8. If we take the square root of -8, it says it's undefined. Here we're going to say it's not a real number. Okay? Because we're going to concentrate on the real numbers. We've already reviewed how if we have a negative under the radical, it becomes an I out front. You can also enter this into your calculator with the fractional exponent, but you would need to put parentheses around that -8. So -8 in parentheses with your exponent, 1 divided by 2 still gets you undefined. 6 to the 0, if I could enter it correctly into the calculator, is 1. Anything to the 0 power is 1. Just so we can get practice rewriting this as a radical, 16 to the 1/4 becomes the 4th root of 16. Okay, if you are in Desmos, you can do the nth root, and you can put the 4 on the index and the 16 as your argument and get 2. Or you could go traditional and do 16 to the 1/4. It's the same thing. Either way, we get 2. However, in our next one, notice that there are parentheses around the 16, negative 16, becomes the 4th root of negative 16, which means we're going to fall into the same trap that we did in part C. We're getting into the imaginaries. So we're going to say not a real number. Example number 2, we're going to get into our variables. And we only want positive exponents for our answers. Okay, so just a quick review. When we had x times x, we got x squared. And that was because we had each of these little x's with an exponent of 1. We had x to the 1 plus 1, which gave us x squared. So when we are multiplying w cubed and w to the 4th, multiplication makes us bigger, so does addition. We're going to get w to the 7th. Whenever we have our division, division makes us smaller, and so does subtraction. So we're going to have x to the 8th minus 3, which gets us x to the 5th. Back in the day, you may have seen this written out when you were first learning these exponent rules, 2, 3, 4, where you would write out all x to the 8th and x to the 3rd. And you would cancel out the x's from top and bottom. And since you were left with 5 x's times each other, you got an x to the 5th. We don't have to do this right out because we remember the exponent rules. All right. In part C, when we have an exponent raised to another exponent, you get to multiply the exponents. So we get y to the 35th. The reason that this works is if we had y to the 5th to the 7th, that means that we would have y to the 5th times itself 7 times. So we would add all of our exponents, and 5 added to itself 7 times gets us 35. Now, in part D, there are a couple of different ways that you can do this. So let's talk about option 1. Option 1 is straightforward. We're going to use the rule like we did in part B. That's where we take z to the 9th and we subtract the exponent from the bottom, which is negative 2. So z to the 9 plus 2 gets us z to the 11th. Our second option is to first rewrite our denominator to be positive exponent by moving him up, which means we have z to the 9th times z squared. And whenever we're multiplying, we get to add the exponents, which gets us to z to the 11th. Either option is fine. It's which one do you see? Same thing on part E. We also have 2 options. Actually, there's more than that. I'm just only going through 2. Option 1 goes straight forward. We would take t to the 4 minus 6, which gets us t to the negative 2. But remember that we cannot have negative exponents. We want only positive exponents. Any whole number can be rewritten as a fraction over 1, We're going to move this guy to the bottom to make his exponent positive and get 1 all over t squared. Your second option, we know that the denominator has the bigger exponent. And we know division makes us smaller. We're going to be subtracting. Denominator has the bigger exponent, so the answer will be in the denominator. So the other way you could do this is do 1 all over t to the 6 minus 4. So still doing the subtraction, except we're keeping the subtraction in the bottom because the 6 is bigger than the 4, and we still wind up with 1 all over t squared. Last one, and I know most of you don't know Oprah anymore, and she's not as big as she once was. But the thing about Oprah was she used to give prizes out all the time. And whenever we have parentheses like this, that's all multiplication and division on the inside, you get to pretend that you're Oprah. And by that, I mean everybody gets taken to the third. You get a third, you get a third, and you get a third. Okay? So by that, we're going to have 3 to the third times x squared to the third all over 4 to the third. Remember, we're not multiplying. This is an exponent. So if we do 3 cubed, we get 27. And if we do 4 cubed, we get 64. And remember, with our exponent raised to another exponent, we're going to take 2 times 3, which gets us 6. So we have 27 x to the 6 all over 64. And because the 27 and 64 don't have anything in common, we don't have to worry about reducing.